So I've got here a setup ready to go for a titration. The first thing I've got is this burette right here. This is a very exact burette. It's made specifically for titrations. What it's got is along the side here, there are very exact measurements going from 50 to 0. And these are milliliters. So it's got about maybe half an inch along this pipe is 1 milliliter. So it allows you to be extremely exact with how much volume you're adding. On top of that, the actual contraption for releasing fluid is also very exact. So I'm just going to take a sample beaker here. I can drop that much at a time, and that's only going to be about 1/5 of a milliliter. So this lets me get extremely precise measurements. So what I'm trying to do is discover the concentration, the molarity of some hydrochloric acid. Remember, I had to pick some hydrochloric acid up from the hardware store, and this is labeled in percentage of concentration, which is an extremely useless way to measure the concentration of anything. If I wanted to just do the calculations to convert that into molarity, I would actually have to go through, measure the density, the weight, and the volume of a sample of that acid. That would be a huge pain to do. It's almost as much work as it would be to just titrate it. So that's what we're going to do. We're going to titrate this, which is probably going to give us a more accurate sample anyway. What I've done right off the bat is I've taken that concentrated hydrochloric acid and I've diluted it by 1,000 times. The reason for that is so that I'm not having to play around with concentrated hydrochloric acid. That stuff, it gives off a fume, it stinks, it is very dangerous to be around. So the solution I have now is 1/1000th the strength of my initial solution. So even if I did get this on me, it probably wouldn't really be a big deal. In the burette, I have sodium hydroxide. This I've also diluted. I've got a stock strength that I keep on hand. This has also been diluted by 1,000 times. So what I know right off the bat is I know the concentration of the sodium hydroxide, and I know the volume of the hydrochloric acid. So I've got that written up right here. I know my NaOH. The concentration I'm using is 0.0158 molar. The volume of hydrochloric acid that I'm titrating is 25 milliliters. So I've got that set up right here. I've got my magnetic stirrer all ready to go so that it'll be very easy to keep this moving around. Otherwise, I'd have to kind of swirl it by hand as I'm going. That would be very obnoxious. And so the next thing I need to add is some indicator. So I'm going to be using phenolphthalein. This is an indicator that will change its color drastically at a pH of exactly 7. So anything below 7 will be completely clear. You won't see it at all. But anything above 7 is going to be a bright pink. And we'll see that as we start to add the base to this, we'll see it start to turn pink and then clear up. That's because the base will react with the acid and then be neutralized. We're going to titrate this until the whole thing stays a steady, solid pink. And once we get to that point, that's when we know how much base it took to neutralize the whole thing. When we know that, then we'll know the volume of base, which will allow us to calculate the number of moles of base, which will allow us to figure out the number of moles of hydrochloric acid and thus the concentration. So just a little bit of backwards work there. And it's really not as complicated as it sounds. So I've got my titration all set up, ready to go. The last thing I need to do is I need to read my initial volume of sodium hydroxide. Because instead of trying to get this exactly to 0, we just take an initial reading and subtract that from our final reading. And that's how we know how much we've actually added. So my initial reading, let me get this out of the way so it doesn't accidentally drip in. My initial reading is hot dog, 1.1 milliliters. So I'm just keeping track of it over on my window here. My initial reading is 1.1 milliliters. So NaOH initial 1.1 milliliters. And then I'll take a final volume reading, and that'll give me the actual volume that I had to use to titrate this. So let's get started. Turn this up. Okay. And I'm just going to start adding my sodium hydroxide. Let's make sure it's nice and centered here. I don't know if you can see that on the camera. Let me actually move this closer. So as I go, you should be able to see the pink as it hits the liquid. And as I go, it takes longer and longer for that pink to clear up. As it starts to take longer, that's how I know I'm getting close to my actual value. Generally, when you would do a titration, you would do it in threes so that you could get close to your first titration would give you pretty close to the actual value. And then from there, you'd be able to just drop some in until you started to approach that, and then you'd be able to get really precise with it. So your last two titrations would be very close to the exact amount, and that would tell you, how accurate of a result you're getting. But I'm just going to do one. We could probably call that good, but it's still clearing up a bit, and I want it to be a nice, clear, solid pink. That's what we're looking for. Okay. So, then I take a final volume reading. It looks like my final volume is 13 milliliters. 13 milliliters for the final. And so my difference is going to be just 11.9. So it took 11.9 milliliters to fully neutralize 25 milliliters of that hydrochloric acid. So we can do some simple calculations. So we already know that our neutralization reaction is HCl plus NaOH neutralizes to H2O plus NaCl. And so we know that this is going to be a 1-to-1 ratio. So we don't need to do anything special with our calculations here. So we have this nice handy little shortcut that the number of moles here is going to be the number of moles here. So let's calculate the number of moles for NaOH. It's going to be 0.0158 times my volume of 0.0119 liters. That's going to be 1.88 E negative 4. Okay? So my number of moles of hydrochloric acid will be the exact same. So it's going to be 1.88 E negative 4. So then we can divide it by our volume to determine our final concentration. So I take 1.88 E negative 4 divided by 0.025, and that gives me 7.52 E negative 3. So remember, I divided that by 1,000 initially. I diluted that by 1,000 initially. So my initial concentration would be 7.52 molar. So what would the pH of this be then? Well, my pH of this hydrochloric acid in this beaker right here, that I can find by just taking the log of that. And I get a 2.12 for my pH. Now that's a lot more precise than using just a regular pH indicator. So the value of a titration is really that we can get a very precise result. A pH indicator might tell me that it's somewhere between 2 and 3 on the pH scale, but a titration tells me that it is exactly 2.12 for pH.